Hey guys, welcome to another Swift deep dive. And in this deep dive, we're going to talk about Swift extensions. Now, recently I discovered that apparently the very first London Underground was built in 1863, which is actually crazy if you think about it. That was like the time of horse and carriages, but okay, maybe a little bit later than that. But imagine that if you build an underground or a train line, it's pretty likely that as your city grows, you're going to have to add extra lines, extra stations, and extend the train line. So this is kind of similar to how Swift extensions work. Extensions essentially allow us to add extra functionality to our existing classes, structures, or other data types. And so that means if you build a project and it was really, really great, but then your boss comes along and says, actually, you know what we need to do for the next quarter? We need to add all of these extra capabilities. Instead of diving into the original code and ripping bits out and switching things around, we can simply just extend the functionality of our existing code. So the way that we would create an extension would be something like this. We would have the extension keyword, and then we can have the name of an existing type. So that could be a class, that could be a struct, that could even be a protocol. And then inside the extension, we would get to add some new functionality to that type. So here I have a blank playgrounds, which I've named extensions. And notice how I'm importing UIKit now, because I'm actually going to use it in the demo. So the first thing I want to show you is how we can extend a custom type. So for example, we know that we can create a double. Let's call it my double and set it equal to 3.14159, the value of pi. And we can round it down to however many digits we want to by turning it into a string. Let my rounded double equal string with a format of %.1f. Let's say we wanted to round it to just one decimal place. And then we put in the my double as the argument that we want to round. And now if I simply print my rounded double and run my code, then you can see that I get 3.1. So that's rounded to one decimal place. Success. But what if I wanted instead to not create a string? What if I just wanted another double, but it was rounded to however many digits I wanted it to be? Well, in that case, what would I have to do? Well, I could use an existing function that all double data types have access to, which is called .round. But unfortunately, what .round does is it will round it down to a whole number. So let's change this let to a var and run our code. And you can see that once that's rounded, my double.round has now produced 3. But I actually want to specify the number of decimal places. So for example, I could say round 2 and then I could say 3 places. So put an integer in there. But this method, round to however many number of decimal places, doesn't exist for the double data type. So what can we do? Well, we could simply create it ourselves, right? Let's create an extension up here. And we start off using the extension keyword, and then we specify the type that we want to extend. So we want to extend the native Swift double data type. So it doesn't even matter that we didn't create this data type or the fact that we don't actually know how it's done. All we need to know is that we're going to get hold of the existing double data type. We're going to give it some new functionality, some new superpowers. And this functionality is going to be in the form of a method, which is going to be called round as well. And notice how Swift allows you to create new functions that have the same name as an existing function, like the round function, as long as we have different parameter names. So in this case, I'm going to have an external parameter name of 2 and an internal parameter name of places. So that means we round to however many number places, and this is going to be an integer data type. So now within the body of my function, I have to figure out how to actually do this. Well, if we take a look at our double, if we want to be able to use the round method, but modify it to be able to round to a certain number of decimal places, what we would have to do is first we would have to take my double and then multiply the existing value by, say, let's say that we wanted to round it to 3 decimal places, right? Then we would have to multiply it by 1,000, so 10 times 3, and then we would take this new value of my double and then apply round to it. And finally, we can take my double and set its new value to be equal to the current value divided by 1,000. And when I run all of that code, you'll see that in the first step, 3.1415 becomes 3,141. And then we round that off to an integer, 3,142. And then we divide it by 1,000 again to get 3.142. So that's the process. So let's try and replicate this inside our round to places function. So first, we have to figure out how can we get 10 if they only wanted to round to 1 decimal place, 100 if they wanted to round to 2 decimal places, and 1,000 if they wanted to round to 3 decimal places. Well, we could simply create a number called the precision number, let's call it, and we can set it equal to 10 to the power of the number of places they want to round it to. So it's effectively saying that if they want to round it to 3 decimal places, then it's going to be 10 times 10 times 10, but it's much easier using the power function. And then we want to set 10 to the power of the number of places. So if we run this code as it is and we try to round my double to 3 decimal places, you can see that right now precision number is equal to 1,000. Whereas if I try to round it to 5 decimal places, then precision number is going to be 10 to the power of 5, which is 100,000. So that's working. And let's change that back to 3, and now let's try to use this precision number by implementing this calculation. The next thing I'm going to do is I'm going to say let n equals self, which is the current value of the double. Notice how we're inside the definition of the double. So when we create a new double like so, then this will be the value of self right here. So if we let n equals self, and then we say n equals n multiplied by the precision number, so this line right here, but instead of using 1,000, it depends now on the number of places that we want. And of course, if we want to change this n, we can't have it as a let, we must have a var. And then we're going to say n dot round to round it down, and then we can write n now equals n divided by the precision number. And finally, we're going to return n as the output of this round method, and we can specify that it should be a double that comes out. The very last thing we have to do is we have to convert this places, which needs to be an integer when the user is calling it, because we don't want them to try to round it to 2.3 places. That doesn't make any sense. So it has to be a whole number. But once it's inside here, we want to make sure that we're all working with the same data type. So in this case, because we have an integer to the power of an integer, we end up with a decimal number. But what we actually need is this to be a double so that we can multiply a double by a double, because otherwise our data types won't match and Xcode won't let us actually do the calculation. So in order to solve this, all that we have to do is just convert our places from an integer to a double. And now you'll see that we can now delete this code here, and I can simply round my double using this new round method that I've added that all doubles can now use, and I can specify the number of decimal places. And now I get 3.12 if I round it to 3 decimal places, and I will get 3.1 if I round it to just one decimal place. And now that we've added this extension, whenever we create a new double, we can simply tap into that capability that we've now given to all doubles, round to a certain number of decimal places. Now, because the double actually comes from the Swift standard library, which is in fact open source, so you can actually see the source code of it when you head over to the GitHub repository that Apple has. Now, if you dig through all of this, you'd actually be able to see the code of how it's implemented. But with other things, especially things that come from UIKit, say our UI view controller, UI text field, that of course is not open source code. So we actually can't see how it's implemented at all, and we don't have access to the code that's used to create a UI label or a UI button. But what we can do in this case is we can, in fact, extend those classes even though we don't actually have access to it and we can't see it. Let me demonstrate. So let's create a new button, which is going to be created from the UI button, and then let's initialize it with a frame. So the frame is going to be a CG Core Graphics rectangle, and I'm going to give it just 0, 0 for position, width and height, I'll say it's 50 by 50. So now that we've created our button, let's go ahead and give our button a background color so that it's actually visible. So I'm going to say it's a red background color. And now if I run my code in Playgrounds and click on this little square here right now, it'll actually show me that element that I've just created, my red 50 by 50 UI button. So now what if I wanted to have a round button? Let's say I wanted a circular button. Well, I could simply just tap into the buttons layer property dot corner radius and set that equal to, I don't know, maybe 25, and then say that button dot clips to bounds equals true. Well, now once these two lines of code have run, you can see that my new UI button is now a circle because the corner radius is now 25 pixels, and if the width is 50, then that means it's actually just a circle. But I don't want to do this every single time I want to create a new circular button. So why don't I add this capability to the UI button? So I can do that using my good old extension, and I'm going to extend this code for the UI button class, which I can't see. I don't know what it looks like, but I do know that I want to have a function called make circular. And in this case, all that it's going to do is it's going to take the current button, so we can address that with self, set the clips to bounds to true, and then I'm going to set the self.layer.corner radius to be equal to the current button's frame.size.width, and I'm going to divide that by half to get a circular button. So now I can use this extension by creating my button after I've created my extension. And now I can say button dot make circular. This is now a valid method that all UI buttons have. And when I run it, you'll see exactly the same thing happen. I now have a circular button created. Now, another thing that we can do with extensions that's really handy is we can actually extend our protocols. If we simply define our extension, adding in a protocol instead of a class or a struct, we can actually define the default behavior for the required methods. So here I've got that file, the protocols demo that we created earlier on when we were learning about Swift protocols. And one of the things that you might have worried about is that when we have a class, say bird, which has the functionality of fly, well, once we've defined this method, say the bird takes off into the air, then we can actually inherit this capability by inheriting from the bird class. And now we don't actually need to implement a fly method, and we can already simply say myeagle.fly. And that would actually call the method in the superclass bird, and we have it because we're inheriting from bird. Now, how can we do something similar with protocols? How can we avoid having to write out the same method implementation if we wanted to keep it the same? Well, in this case, where we've created our protocol can_fly with a required method of fly, we can actually define a default implementation by extending our protocol can_fly. So now that we've got this extension of our can_fly protocol, we can implement the fly functionality, and we can say that whenever a class or a struct adopts this extension, it automatically has access to a default version of the fly method, which just says the object takes off into the air. So now, once we adopt can_fly, we don't actually have that error anymore, which says, hey, you said you can fly, but you haven't adopted the fly method, because we've already got a default implementation that it's going to fall back on. So now when we say something like, let my plane equal airplane, and because this airplane already adopts the can_fly protocol, I can simply say myplane.fly, and it will already know how to fly because it's just going to look at the default implementation that comes from that protocol can_fly. And once my code runs, you can see that's the one that it's executing. So this is also what's happening when we adopt our UI text field delegate, but we're actually not required to implement any of these text field delegate methods. You can see that even if I comment them out and I hit Command B to build, and we've got our UI text field delegate implemented, I'm not getting any errors here. These are all optional because they already have a default implementation. And in fact, when you take a look at the UI text field by option clicking on it, you can see that it's got loads of delegate methods. Imagine having to implement all of them. But in this case, we don't have to because they all have a default implementation. So that's the core functionality of extensions. You've created something already, you want to give it more functionality, you want to extend the train line, you create an extension of that data type and add the new functionality inside the curly braces. The last thing I want to talk about on the topic of extensions is that they can actually be really handy for organizing our code as well. Because for every data type, we can create an extension that adopts a different protocol. So for example, in our code here, if we have a lot of delegates, you can see that it's going to start building out in this class definition here. And our code is already getting quite long and quite messy. So we can simply extend our weather view controller class, and for each extension adopt a different delegate protocol, and then have all of the code organized into separate extensions. So that's what we're going to do in the next lesson.